explains the ranges. It goes over the subnetting chart for Class C only, and I'm focusing on the /26, and I will relate the binary to the decimal expression. Here we are. We have our Class A, which has ranges between 1 through 127. Class B have ranges between 128 through 191 in the first octet. Class C has a range between 192 and 223 in the first octet. Class D is 224 to 239. Class E is 240 through 254 in the first octet. As you see here, I actually did the longhand expression though. And basically for the Class A, you have 1.0.0.0 through 127.255.255.255. Let's take a minute to really focus on why we have these 255s. There are 4 octets in a 32-bit address. There are 8 bits per octet. Per octet, each bit has a corresponding number and bit position. Let's look at the chart below. So we have here 128, 64, 32, 16, 8, 4, 1. Add these all together, we get 255, which simply means all host bits, or all bits, network or host, are turned on. So now, let me bring your attention to this subnet mask here. This is the chart that I was referring to that when I go on my interviews, or used to, for level 1 network engineer positions and level 2 network engineer positions, I would draw out this chart specifically. Is because in these interviews, you generally always get an IP subnet question, and honestly, usually it's either a /26 or a /28. I don't think nobody asks the /30 question anymore. And so let's focus on this. We have 2 bits borrowed from what we're claiming, and we have a subnet mask of 255.255.255.192. So let's look at this. Let's understand the subnet mask as it relates to the IP address. Remember, we're focusing on Class C here. So when we say 255.192, really we're saying that all bits here are turned on, all bits here, and all bits here are turned on, and we have 2 bits turned on here. I'll show you what I mean by that. Remember this this chart that I was just speaking about, 128 plus 64, 32, 16, 8, 4, 2, 1? Well, these are the very bit positions that are in each octet. Remember, each octet is 8 bits. So that means that all bits are turned on here. In this first octet, which is 255. All bits are turned on here, which is the second octet, 255. All bits are turned on here, which is why we have 255 here as well. You turn on all bits, and then we have 255, which is the broadcast. And then, notice here where it says we borrowed 2 bits from the last octet. Well, here it is. We borrowed 2 bits. We borrowed the 128-bit position, and we borrowed the 64-bit position, which equals 192. That's why we have 255.192, and we're saying that we borrowed 2 bits from the very last octet. Okay, from the 4th octet. So let's count this up, because we can actually relate this to our CIDR notation, which is classless interdomain routing notation. So we have 8 here, 8 here, 8 here. Okay, so 8 times 3, that's 24, plus 2, 26. So we're saying that we use 26 bits out of a 32-bit address. Now, when a customer asks you or an interviewer asks you, how many hosts is in a /26? If you memorize this chart, you will simply tell them, well, there's 62 hosts per subnet, and there's 2 subnets. So you can give an example of something as similar as this. 200.128.64.0/26 is the network or subnet. Your usable host will be 200.128.64.1 through 200.128.64.62. Your broadcast is going to be 63. Now, broadcast IPs are what is used by routers to obtain the ARP address resolution. Now, let's focus back up here for our first host, invalid host, and the broadcast that I was just talking about. So, we have the first valid host of being 1, which I was just talking about, in a /26 with the network mask 255, 255, 255, 192. We have the last valid host, 62, in the broadcast, which is only usable for broadcast traffic for the use of ARP. And then we have the subnet that it's on. So the easiest way that I remembered this entire chart, believe it or not, is I'm good with remembering patterns as are most people. So I took these numbers here, 5 numbers, 2, 6, 14, 30, and 62. If you could remember 2, 6, 14, 30, and 62, and just reverse them, 62, 30, 14, 6, and 2, now you basically did most of the work. You already memorized the number of subnets and the number of hosts per a /26. Another easy thing to remember is 192, 224, 240, 248, and 252. And then remember 2, 3, 4, 5, 6. Remember it. I use that pattern to remember this entire chart, and I can produce it at will at any time. This will get you through most subnetting questions. Sometimes, I remember once an employer asked me a Class B subnet question, and it took me a second. I had to think about it. I believe it was a /25, and they wanted to know how many usable hosts was in a /25. Notice /25 is not on here. And my answer, after I thought about it, I was just like, so your first valid host would be 1, your last valid host would be 126, your broadcast would be 127, and the subnet is 128. Or the next subnet, which actually would be invalid, because that is the end of a /25. Now, a /25 network mask, so we have /26 here. /25 would be if this one right here was a 0. So that would mean we have 25 bits turned on. So that would look like 255, 255, 255, not 128. So